Welcome to this Eonfusion tutorial on metadata. This tutorial will provide you with an understanding of the importance and usefulness of metadata in Eonfusion. It is assumed that you have already seen the overview tutorial. This tutorial will focus on how to set metadata in Eonfusion and how it works. Metadata is set using the metadata operator. The metadata operator can exist as a standalone operator created via the new operator menu. However, it is also included in many operators and data sources as an additional tab in the Properties window. These settings allow you to specify the metadata for this operator. The first part of this tutorial will be dedicated to these metadata settings. We will examine the settings in detail and work through the process of setting metadata. It helps to resize the metadata properties window to the largest practical size. You can see that the metadata properties window is made up of 4 panes. Here at the top left is the attribute group selection pane, where we select the attribute group for which we wish to set metadata. The attribute groups available for selection are highlighted in white, and the selected attribute group is shown in this text field at the bottom of the pane. If we click on the 0D points attribute group, then the name of this group is displayed at the top of the metadata table at upper right, and the attribute in that group appears in the table. The individual values of the ID attribute then also appear in the input table at lower left and the output table at lower right. Likewise, if we select the vertex attribute group by clicking vertices, then the vertex attributes appear in the metadata table and the input and output tables. It is important to set metadata for each of the attribute groups in a dataset. This pane here at the top right is the metadata table, where the metadata is defined for each of the attributes in the selected attribute group. The pane here at lower left is the input table, which shows the data in the form in which it enters the metadata operator. In this case, it is the data that is read by the tabular text data source. And at lower right is the output table, which shows the data in the form in which it leaves the metadata operator. These two tables together provide a useful visible indication of the effect of the metadata settings on the data. Now we will look at the metadata table in more detail. In this case, we're looking at the metadata table for the vertex attributes. Starting at the left, this first column is the attribute column, which lists the available attributes by name. The second column is called the changed column. This consists of a checkbox for each attribute. The checkboxes are checked. The metadata for the corresponding attribute has been changed by this metadata operator. If the checkbox is unchecked, it means that the metadata settings have been inherited unchanged from previous metadata operations. This is a useful diagnostic because in complex data flows there are likely to be many metadata operators. It is useful to be able to quickly and easily assess whether a specific metadata operator has implemented changes to the metadata. The third column is the data type column. This setting defines the form in which data is to be stored in memory. The available options are shown in this drop-down list. The 4 most commonly used data types are listed at the top. These correspond to logical or Boolean data, text strings, real numbers, and integers. You can read more about the use of data types in the Eonfusion manual. A useful rule of thumb to begin with is to use the real data type for numbers and the text data type for text. The projection column shows the projection metadata for a given attribute. These geographic projections are usually set for multiple spatial coordinates at once. This is achieved by selecting the attributes that are to be included in the projection group, then clicking the Select Projection button at the right. This yields the Select Projection window, in which we can specify any one of a large number of projection types, datums, and where relevant, individual zones. It is important to know that once projection metadata is set for a pair or group of attributes, it can only be reset or changed for that same pair or group of attributes. Defining a projection enables Eonfusion to convert between projections when required. We will look at projection metadata in more detail later in this tutorial. The usage column is a very important part of the metadata specification. It allows you to map specific attributes to a notional purpose for their use. This in turn allows Eonfusion to make smart decisions about how to use those attributes. An example is the scene view, which by default maps the attributes with usages spatial x, spatial y, and spatial z onto its x, y, and z coordinates. It also maps the attribute with usage time onto the time coordinate. Setting these usages as part of the metadata allows the scene to automatically map attributes onto the relevant coordinates. The unit type and units columns together specify the unit metadata that is applied to the attribute. The unit type column refers to the physical quantity that is represented, while the unit column refers to the units in which that quantity is specified. The unit types that are made available are based on the specification of usage, and the units that are available are based on the specification of unit type. We see here that when usage is specified as time, the only unit type available is time, and the choice of units is confined to a set of time units. Specifying units is important because Eonfusion can then convert between different units when required. We'll scroll across now to look at the final three columns. The input format column is used for specifying the form that the data takes in the input. A suitable example in this case is the date-time attribute. The data type for the date-time attribute has been set to real because it is a coordinate and therefore must be stored as a number. However, the input data is not stored as a number, but rather in a commonly recognized time format, as we can see in the input table at lower left. Setting an appropriate input format enables Eonfusion to understand the input data as a number, even though it may be represented in a way that is not purely numeric. The output format works in a similar way. It does not change the stored data values, but alters the way that they are represented. We can see that the output format for the date-time attribute is general, hence its representation in the output table at lower right is as a number of seconds since midnight on the 1st of January 1970. We can see that by changing the output format, the representation of the data in the output table changes. It is important to note that the output format is related only to presentation and does not affect the data that is stored. The final column in the metadata table is a comments column, where you can enter relevant comments about a given attribute. These can be helpful when sharing data flow with others. We will now look at the process of defining metadata from scratch. To do so, we have created a new tabular text data source which points to the same file as the data source that we've considered previously. Opening its properties and going to the Metadata tab, we can see that no metadata is defined. First of all, we need to select the attribute group for which we wish to set metadata. As an example, we will look at the vertex attribute group. At this point, the metadata are all default values, and the change checkboxes are all unchecked to indicate that the values are defaults. A useful first step is to click the Analyze button at the upper right of the metadata table. This prompts Eonfusion to make an attempt at automatically assigning metadata. The attempt is based on the names of the attributes and on the types of data that appear to be present. We can see here that date time has not been recognized as a standard coordinate name, and so its metadata has been left unchanged. However, the lon and lat attributes, longitude and latitude, have been recognized, and Eonfusion has made assignments of data type, usage, unit type, and units. The checkboxes in the changed column have also been updated to indicate that metadata has been assigned. So the next step is to manually define the metadata for the date time attribute. We do this by setting the data type to real and the usage to time to begin with. You can see that setting the usage to time immediately sets the unit type to time and the units to time by default. We will leave these unchanged. We now need to specify an input format for the date time attribute. Looking at the input table, we can see that the date time input data is in a string format, where Eonfusion by default is looking for a real number. Hence, the corresponding column in the output table shows no data. If we set the input format to a form that matches the input string, we can see that the data is read and that the output table updates accordingly. Finally, we can set projection metadata for the spatial coordinates lon and lat. This is done by selecting both rows and clicking the Select Projection button. In the Select Projection dialog box, we choose the relevant projection type, in this case geodetic, and we choose the datum, in this case WGS84. Geodetic projections do not require the specification of a specific subtype or zone, and the type and datum are all that is required to specify the projection. The metadata for this vertex attribute group is now set up in the same way as the metadata in the early part of the tutorial. It's important to note that we have not set metadata for the 0D points attribute group. This would be required to complete the metadata specification for this dataset. The metadata settings are summarized here in the data structure selector in the upper left-hand pane. Attributes are grouped under their projection, which is shown in blue text. Usage is listed in green alongside the attributes for which it is defined. The icons immediately next to the attribute names indicate the data type. In this case, these D icons represent the real double data type, and over here in the 0D points we can see this T icon which represents the text data type. We'll now look at some examples of the effect of changing the defined metadata. We'll do this by creating a new metadata operator. Opening the properties of the new metadata operator, the metadata tab is the same as in the tabular text data source. Looking at the metadata for the vertex attribute group, we can see that the change checkboxes are all unchecked and that the metadata values have been inherited unchanged from the previous metadata operation. As our first example, we will change the projection of the lon and lat attributes. We'll change the projection type from a geodetic to a universal transverse Mercator or UTM projection. The datum remains the same, but a specific projection must be chosen corresponding to the relevant UTM zone. In this case, the data are located in zone 55S. Clicking OK applies these settings. The new projection metadata is now visible in the metadata table, and the change checkboxes have been updated to indicate that changes have been made. You'll see that the unit type and units have also been updated. Comparing the input and output tables, we can see that the input longitude and latitude values in degrees have been converted to UTM easting and northing values in meters. Another simple example of changing metadata is a change of unit. If we change the unit metadata for the date-time attribute from seconds to days, we can see that the output values in the output table have been changed to reflect the change of units. These examples show that changes to defined metadata manifest as actual changes in the data values themselves. As a final note on projections, we'll look at the properties of a scene view. The scene has projection, usage, unit type, and units metadata for each of its four axes, X, Y, Z, and time. Projection metadata for the scene axis enables the scene view to automatically convert the projection for geographic data that is input to the scene, if a conversion is required. However, this can only work if the input data has projection metadata. The usage specification enables the scene view to automatically allocate the relevant attributes to the four scene axes. This works best if the input dataset has one and only one attribute mapped to each of the four usages that are specified in the scene properties. In both of these cases, the upfront investment of setting metadata will save significant time and effort in other parts of your workflow. We hope that this tutorial has been a useful introduction to metadata in Eonfusion. Please take the time to view our other video tutorials to help you get started. Thank you.